Okay, so in a previous video I talked about AND versus OR problems. And the OR problems were the ones where we were adding things up and subtracting the overlap. AND problems are going to be a little bit different. So when you see the word AND in a problem, it typically tells us that we're going to need to multiply. So the probability that something happens, and then right after that something else happens. Sometimes you'll see the word then instead of and, but it kind of means the same thing. So the probability that maybe it rains on Wednesday and then it rains on Thursday would be the probability that it rains on the one day times the probability it rains on the other day. Okay, again, very basic sort of introduction to this, but that's mostly what you'll need to know for now. Sometimes you have to be a little bit careful though, because things can change from one event to the next, and we'll talk about what to do when that happens. Okay, so we'll start off here basic with dice problems. So let's say we have a six-sided die, just like you'd normally have in Monopoly or something like that. And let's say that you wanted to find the probability that you roll a 6 followed by another 6 right after that. So let's say you roll basically a 12 if you were to roll both the die. So what would the probability of rolling that be? So to roll a 6 and then another 6, we first need to find the probability that we roll a 6. And since there's one number on the die that's a 6, and I'll draw it here just so you can see it. So there's one number on the die that looks like that. Out of the total of 6 numbers, that would be the probability we get 1 6. But then to roll a 6 again, we'd have to multiply that by the probability that we roll another 6. So if we multiply these guys together, we'll see that to roll a 6 and then another 6, or basically 12 in Monopoly, there's only a 1 in 36 chance of that happening. Okay, there's a little bit more there at play when you look at odds and probability and the order that the dice come up. But for now, that's a little introduction. So the probability that we roll a 5 and then an odd number. Okay, so first to roll a 5, again, there's only one number on the die out of 6 possible numbers that's a 5. And then we'll multiply that by the probability that we roll an odd number. Now for the odd numbers, there's two ways to write this. I'll write it this way. There's 3 numbers on the die that are odd out of 6, but you could also write that as 1/2. Same thing. And if we multiply this, this should reduce to 1 over 12. Again, not getting into the difference between probability, odds, chances, all that stuff here. Just going to keep them as fractions for now. Maybe we'll do a decimal later. Another possibility, we could say, okay, what's the probability we don't roll a 4 and then we roll an odd number? So let's try this one out. So if we're looking at something that's not a 4, there's only one number on the die out of 6 that is a 4. That means that 5 of the numbers out of 6 are not 4. And then if we think about the odd number, we already looked at that. That's 3 out of 6, or 50-50, 1/2. And if we multiply these probabilities together, 5 times 1 is 5. 6 times 2 is 12, so we could write that as 5 over 12. Again, notice that these two fractions are really the exact same thing, just written two different ways. Okay, throwing a sneaky one in here. We'll see if you catch it. Probability of a 6 or a 5. Now we have to be careful here. We talked about how with OR problems before, we do not multiply. These are the ones where we're going to add and subtract the overlap if there is any. So we'll start here. The probability of rolling a 6 is going to be 1 out of 6. And the probability we roll a 5 is also 1 out of 6. There's one number out of the 6 numbers that's a 5. And now we're going to add those probabilities up. And on this one, there's no way to roll a 6 and a 5 at the same time. You can't have a number come up as both a 6 and a 5 when you roll it. So if we add these up, we're going to get 2 out of 6, which is 1/3, or 1 out of 3. Okay, we can see in this example too, if we actually counted up the numbers on the die, there would be 2 numbers out of the 6 numbers that could have come up if we wanted to roll a 6 or a 5, which is why that works that way. Now the next one's kind of a tricky one. We've got a multiple of 2 or a multiple of 3. Again, I see the word OR, so I'm sneaking this one in on you guys here. This isn't an AND problem. We'll do more ANDs here in a little bit. But if we think about the die, let's write out all the numbers here just to be safe. These are all the possibilities. This is also referred to as the sample space in probability, all the possible outcomes. Let's start here with multiples of 2. So for multiples of 2, there is 2, 4, and 6. Those are all multiples of 2. So that means there's 3 numbers out of 6 that are multiples of 2. It's an OR problem, which means we need to add. And now let's look here at multiples of 3. So for multiples of 3, I see a 3 and a 6. So that's 2 numbers out of 6. And now it would be a mistake here to just add these up. And I'll let you think for a second about why. You need to pause the video, you can. And the reason this is a mistake is because right here at the end, this 6 is actually an overlapping number. It was both a multiple of 2 and a multiple of 3, so that's overlap. We actually need to subtract that one number away since we already counted it twice. So if we add these up, we get 5 out of 6 minus 1 out of 6 is 4 out of 6, and this probability should be 2 over 3. Okay, so that gets you into some basic dice probabilities, some with some ands and some with some ors mixed in. Okay, we could go back to our deck of cards. Again, if you're not too savvy with cards, go ahead and pull up a picture of a deck of 52 cards and just follow along as we go through this. So if we wanted to draw a probability of a 10 and then a jack, again, if we see the word then, it's sort of an implied and then, which tells us this is an and problem. We're going to need to multiply. So probability of a 10 and then a jack would be the probability of a 10 first. So there's 4 10s in the deck out of 52 cards times, now the key here is these cards are being drawn without replacement, and this starts to make the things a little bit different. Now when I draw a card without replacement, that means when I draw this second card that's a jack, I'm going to take that that 10 out of the equation. So if I pick the 10 out, I'm not putting it back in the deck before I draw that second jack. So now there's 4 jacks left in the deck, but be careful because we took the 10 out, so there's only 51 cards left. Again, I'm not going to go in and multiply these. I'll let you guys do that in your calculators on your own time, but it should be 4 out of 52 times 4 out of 51 for our setup. Next one, again, without replacement, drawing an ace and then another ace. Alright, so the first ace, if we draw that out of the deck, it's going to be just like a 10. There's 4 aces out of 52 cards. Now, you might start to see the pattern here that now there's only 51 cards left in the deck because we're not replacing the ace we took out. But we have to be careful on the top here too. There's now only 3 aces left in the deck because we already took one out. And I urge you to actually take a deck of cards, take one of the aces out, and actually see if you can figure out that probability just by counting up the cards, and that might be another good way to visualize it. Okay, next one's a tricky one. The probability we draw a king, then a face card, and then another face card. So we'll start with the king. King's pretty basic, just like the aces and tens. There's 4 kings in the deck out of 52 cards times. Now we're going to try to draw a face card. There are 12 face cards in the deck out of 52 cards. However, we took a king out, so you have to be real careful here. That means there's only 11 face cards left because the one king right here was a face card and we took it out. Next up, we're going to have to go ahead and draw another face card. So there's 10 now left because we took a king and another face card out. Whoops, I don't know if anybody caught my mistake there. I was sleeping on the wheel. But this 52 right here should actually be a 51 because we took that king out. So it should be 52, 51, 50 counting down since we're not replacing the cards. We got one more here. We're going to take the probability we draw a jack or a black card. So probability of a jack. There are 4 jacks in the deck out of 52 cards. And the black cards in the deck, that's half the deck. So half the cards are red, half the cards are black. So that'll be 26, which is half of 52. Now the problem is that this isn't an AND problem. So we're not going to multiply this. Remember, this is a sneaky OR problem here. So when it's an OR problem, we're going to add the probabilities together and subtract any overlap that we see. So in this case, there's 2 overlapping cards. There's the jack of clubs and the jack of spades are both blackjacks. If you ever played the game blackjack, comes from those 2 cards. So you've got the jack of clubs and the jack of spades, which is 2 cards out of 52 that we're going to have to subtract. And now notice I didn't count down here. I didn't change this to be a 51 here because I'm only picking one card. I'm picking a single card that has to be a jack or a black card. So I'm not counting like 51, 50 on these. Whereas these, it was pick a king, then a face, then another face. That was 3 cards we were picking. Anyway, if we add these up, we're going to get 28 out of 52. Again, if you'd like to reduce that, turn it to a decimal or percent, you're welcome to. But we'll stop there. So that's an introduction to AND problems. Hopefully that helps clear up some of your confusion. And again, that's a real quick introduction to compound probability. There's tons more you can do with this stuff. Hope you enjoyed the video.